Assalamu alaikum wa rahmatullahi wa barakatuh. This is chapter 5 prime numbers part 2. Objectives. At the end of this video, students will be able to decompose a natural integer into prime factors, recognize and use the algorithm of successive divisions, use decomposition into prime factors to find the GCD, use decomposition into prime factors to find the LCM. Materials you will use: your textbook, your copybook, and a pen. Prime factorization. Definition. The prime factorization of a natural number is the writing of this number as a product of its prime factors, which mean divisors. Examples: 50 equals 2 times 25. Writing 50 in this form is not the prime factorization of 50 because 25 is composite, whereas writing 50 as 2 times 5 squared, this is the prime factorization of 50 because all the factors, which are 2, 5, and 5, are prime. The writing of 42 as 2 times 3 times 7, this is the prime factorization of 42 because all the factors are prime numbers. Remark: use successive divisions by prime numbers to find the prime factorization of a number. Example 1. Find the prime factorization of 330. Divide 330 by any prime number that divides it, which means you must obtain a natural quotient. Try to divide 330 by 2, for example, which is a prime number. You will get 165 as a quotient. It is a natural number. Put 2 in front of 330 while you put the quotient 165 below 330. Do the same thing for 165. You must find a prime number that divides it. For example, try to divide 165 by 2, which is a prime number. Your quotient will not be a natural number, so instead of that, try to divide 165 by 3, which is a prime number. You will get 55 as a quotient. So place the 3 in front of 165 and 55 below 165. Similarly for 55, divide it by a prime number that divides it, which is 5. You will get 11 as a quotient. Divide 11 by a prime number that divides it, which is 11. You will get 1 as a quotient. When you get 1 in the quotient, you stop dividing. Finally, after we had found the prime factors of 330, writing 330 in this form is the prime factorization of 330. Example 2. Find the prime factorization of 140. Divide 140 by 2, which is a prime number. You will get 70 as a quotient. Divide 70 by 2 also. You will get 35 as a quotient. Divide 35 by 5, which is a prime number. You will get 7 as a quotient. Divide 7 by a 7, which is a prime number. You will get 1 as a quotient. Then you write 140 equals 2 times 2 times 5 times 7, which is equal to 2 squared times 5 times 7. This is the prime factorization of 140. Don't forget that you have to divide by a prime number only. Application 1. Find the prime factorization of 150. Application 2. Find the prime factorization of 113. Pause the video to solve these applications. Solution. Divide 150 by the prime number 2. You will get 75. Divide 75 by the prime number 3, where you will get 25 as a quotient. Divide 25 by the prime number 5. The quotient will be 5. Divide 5 by the only prime number that divides it, which is 5. You will get 1 in the quotient. So the prime factorization of 150 will be the writing of 150 as a product of its prime factors, which is 2 times 3 times 5 squared. Solution of application 2. Trying to divide 113 by the first prime numbers, you will see that 113 is not divisible by any of the prime numbers. That is because 113 is a prime number already. So we cannot write 113 as a product of prime numbers because 113 is a prime number but 1 is not a prime number, and 113 could be written as a product of 113 and 1 only. Prime factorization of Gcd and Lcm. Let a and b be any two natural numbers. The greatest common divisor of a and b is the product of all the prime factors that are common to a and b with the least exponent. Example: find the prime factorization of the greatest common divisor of 156 and 234. First of all, you should find the prime factorization of 156 and the prime factorization of 234. The prime factorization of 156 will be the writing of 156 as the product of its prime factors, which is equal to 2 exponent 2 times 3 times 13. Whereas the prime factorization of 234 will be equal to 2 times 3 exponent 2 times 13. Now, to find the greatest common divisor between 156 and 234, we have to look for common divisors. 2 is a common divisor between 156 and 234. 3 is another common divisor. Also, 13 is a common divisor between 156 and 234. Now, among these common divisors, we are going to take the common divisors with the least exponent. So the prime factorization of the greatest common divisor of 156 and 234 will be equal to 2 times 3 times 13. Notice that when we had 2 exponent 2 and 2 exponent 1, we have taken the 2 with the smallest exponent, which is 2 exponent 1. Similarly, for 3 and 3 exponent 2, we have taken 3 exponent 1 only. So in the greatest common divisor, you will take the common prime factors with the least exponents. The least common multiple of a and b is the product of all the prime factors of a and b with the greatest exponent. Example: find the prime factorization of the least common multiple of 156 and 234. Also, we should find first of all the prime factorization of 156 and the prime factorization of 234. 2 is a prime factor of 156 and 234, but we take the 2 with the greatest exponent, so we take 2 exponent 2. Also, 3 is a prime factor of both numbers, but we take the 1 with the greatest exponent. Also, 13 is a prime factor for both numbers, since it has the same exponent, so we take it once. Then the prime factorization of the least common multiple of 156 and 234 will be equal to 2 exponent 2 times 3 exponent 2 times 13. Remark 1. Two numbers with greatest common divisor of 1 are said to be relatively prime. Their least common multiple is their product. Examples: let's find the greatest common divisor and the least common multiple of 38 and 15. The prime factorization of 38 is 2 times 19. The prime factorization of 15 is 3 times 5. According to the previous rule, the greatest common divisor of 38 and 15 will be 1, because there are no common prime factors between 38 and 15. Now, according to the rule of the least common multiple, the least common multiple between 38 and 15 will be the product of all the prime factors of the two numbers. So, it will be equal to 2 times 19 times 3 times 5, which is equal to 38 times 15. So, as you see, 38 and 15 are relatively prime numbers because their greatest common divisor is 1, and the least common multiple of such numbers, which are relatively prime numbers, will be equal to their product. Another example: the greatest common divisor of 17 and 18 is equal to 1. The least common multiple of 17 and 18 is equal to 17 times 18, which is their product. Conclusion: any two consecutive numbers are relatively prime numbers. Remark 2. The product of two natural numbers is equal to the product of their greatest common divisor and least common multiple. Example: greatest common divisor of 24 and 36 is equal to 12, and least common multiple of 24 and 36 is equal to 72. Notice that 24 times 36 is equal to 864, which is equal also to 12 times 72, which is the product of the greatest common divisor and the least common multiple of these two numbers. Application 1. Find the prime factorization of a GCD and LCM of 39 and 57. Application 2. Find the prime factorization of a GCD and LCM of 50 and 36. Pause this video to solve these applications. Solution. First of all, you should find the prime factorization of 39, which is equal to 3 times 13. The prime factorization of 57, which is equal to 3 times 19. The greatest common divisor between 39 and 57 will be equal to the product of the common divisors with the least exponent. The common divisors between 39 and 57 is 3 only, and the exponent of 3 in both numbers is 1, so the greatest common divisor of 39 and 57 will be 3. Now the least common multiple of 39 and 57 will be equal to the product of all the prime factors of these two numbers. Since 3 is a common factor, we take it once, so the least common multiple will be equal to 3 times 13 times 19. Solution of application 2. The prime factorization of 50 is equal to 2 times 5 exponent 2. The prime factorization of 36 is equal to 2 exponent 2 times 3 exponent. The greatest common divisor will be equal to the product of the common factors with the least exponent, and 2 is the only common divisor between these two numbers. Here we have 2 exponent 1 and here we have 2 exponent 2. We take the one with the smallest exponent, so the greatest common divisor of 50 and 36 will be equal to 2. The least common multiple of 50 and 36 will be equal to 2 times 3 exponent 2 times 5 exponent 2. Since 2 is common between these two numbers, we are going to take the one with the greatest exponent according to the rule. Assignment. Review pages 60 and 61 from the textbook. Homework. Exercises 28, 29, 30, 31, 32, 33 and 36 pages 65 and 66 from the text. Summary. Prime factorization is the product of the prime factors. The greatest common divisor is equal to the product of the common factors with the least exponent. The least common multiple is equal to the product of all common factors with the greatest exponent. The greatest common divisor of two relatively prime numbers is 1. This is the end of the video. Thank you for watching. Goodbye.